Experts are on the edge of their seats as astronomers have found a mystery bubble in the constellation Cygnus. This cosmic particle accelerator, producing strong gamma-ray bursts, is in stark contrast to the terrestrial CERN. However, it remains shrouded in great uncertainty because we don't know what kind of object we are dealing with. The only certainty is that the hidden structure produces gamma-ray photons in the order of a quadrillion electron volts, making it one of the most potent gamma-ray sources in the entire Milky Way. The foundation for today's video was laid more than a century ago, on August 7, 1912, to be exact. On this day, Austrian physicist and fervent balloonist Victor von Hess ascended to dizzying heights to study a specific phenomenon. He knew that the air on Earth is not completely electrically neutral, but is partially ionized. At the time, scientists assumed that the missing electrons were due to radioactivity in the Earth. If this assumption were true, as Hess thought, then the air ionization should steadily decrease with increasing altitude. However, after the Austrian ascended to 4,000 meters aboard his hot air balloon, he made an astonishing discovery. At that altitude, electromagnetic radiation, known as gamma radiation, was half as strong as it was on the ground. At 5,000 meters above the Earth's surface, the intensity of the gamma radiation had actually doubled. Hess immediately realized that terrestrial radioactivity could not be the source of this radiation. Instead, he proposed a revolutionary idea that this radiation originates directly from the universe. It would take another 25 years and countless debates with his colleagues before the Austrian physicist was awarded the Nobel Prize for his discovery of cosmic radiation. Even though the general term cosmic radiation has been retained to this day, strictly speaking, cosmic gamma radiation is not actually included. But what are gamma rays and what are their sources? Additionally, in this instance, the historical research origins date back to the early 1900s. The British physicist Ernest Rutherford discovered in 1902 that atomic nuclei emit 3 different types of radiation when they undergo radioactive decay. He named the corresponding types of radiation after the first 3 letters of the Greek alphabet: alpha, beta, and gamma. The first 2 are particle beams, while the third represents high-energy electromagnetic radiation. When moving from the terrestrial research sites of the turn of the century into the depths of space, we find that, in contrast to particle radiation, cosmic gamma radiation travels almost in a straight line from its point of origin. This creates a galactic track that, in the best case, leads directly back to its source. When high-energy particles accelerate or decelerate, gamma radiation typically results as Bremsstrahlung or synchrotron radiation. Cosmic rays are the primary producers of these high-energy particles. However, things get more complicated when the gamma-ray source is hidden and draws attention with extreme outbursts that defy every known pattern. The question then becomes, where do the extreme radiation bursts come from? The Earth is constantly bombarded by cosmic radiation particles, most of which come from the Sun, neighboring stars, supernovae, and the Milky Way center. As already mentioned, gamma radiation is another component. Gamma-ray photons with an enormous energy of several peta-electron volts can rain down on our planet. To be clear, these energies are thousands or even millions of times greater than those produced by particles in the Large Hadron Collider at CERN. This illustrates that the elemental gamma forces of the universe are not to be taken lightly. A study by researchers at Ohio State University investigated what would happen if the Earth were struck directly by a nearby gamma-ray burst. The study's unflattering conclusion was that such an event could result in mass extinction. The ozone layer would be so severely affected that the world's food supply would collapse, and the climate and atmosphere would undergo dramatic, long-lasting changes. Experts are mainly concerned with the question of where exceptionally energy-rich gamma-ray photons originate, as this has only been partially explained. On one hand, it is possible that some of these particles come from outside the Milky Way. On the other hand, some may originate from zones within our galaxy, such as the star nursery Cygnus X, located in the constellation Cygnus and 4,600 light-years away. This structure contains hundreds of hot, massive young stars and several densely populated star clusters. A spectacular discovery was made here by a research team using the Large High-Altitude Air Shower Observatory in China. To put things into perspective, the specialists found 8 events with energies greater than 1 peta-electron volt, more than a quadrillion electron volts, and approximately 3,200 gamma photons with energies over 400 tera-electron volts. Previously, scientists believed that cosmic rays with such high energy were more likely to originate from extragalactic sources. This discovery within our Milky Way was surprising, to say the least. It raised the question of what background mechanism in Cygnus X could be accelerating atomic particles to almost the speed of light. The researchers determined that the detected values could only be explained if the particles were accelerated to energies of at least 20 peta-electron volts. This significantly outshines the average observations in the Milky Way. In other words, there are sources in our galactic home capable of producing cosmic radiation at such high energies. But what are they? To find answers, scientists analyzed the intensity distribution of emitted gamma radiation. They concluded that the high-energy protons originate from a point source in the center of the Cygnus bubble. This area also contains a massive star cluster Cygnus OB2, home to some of the most massive and luminous stars known. Some are 100 million times brighter than the Sun. Astronomers believe that the immense luminosity and strong stellar winds of these young stars turn them into genuine particle accelerators. These stellar winds, reaching speeds of 3,000 kilometers per second, combined with their location, age, and energy values, makes Cygnus OB2 the most promising candidate for a cosmic gamma-ray factory. However, this remains a theory. We do not yet know which unknown structure is responsible for these extraordinary observations. Future research will hopefully provide clarity.